Fjordman. I'm coming from Schulze Pumps, Denmark. I have worked with a compressor and pumps my entire work life, and I work a lot with energy saving. Because energy saving is one of the things. This is quite easy to work with in Denmark because we have a lot of old treatment plants where we can choose better solutions. And this is what we are doing in Schulze, and this is the last time I will say the Schulze name. When we are talking about selection of compressors or blowers, this is important to know what is the expected lifetime of the treatment plant. Do you have this treatment plant for a few years, or do you have it for many, many years in the future? If you have that, you should look into a LCC calculation, how to make the best installation over time. What is your budget? If you have a very high budget or low budget, then you can make your investment over some years. I have made several installations where we selected what will we like to have in the future, and then I come back and we install one machine each year. But before we starting this one, we need to know something about how much air do you need, what is your demand. We also need something about the maintenance cost, because we need to use the maintenance cost, energy consumption to make the best LCC calculation. And then there's one thing that happened in the last years in Denmark. This is we are build bigger water companies, and then we have no employees on each treatment plant. So today the company often have to have some equipment that have a lot of information coming back through the SCADA system, because there's no one to go on the treatment plant and look after the blowers, look after the pumps, look after everything. So they get all the information back to the major treatment plant. And this is also one of the things we are talking a lot about in Denmark. The water level in the tank, we cannot do anything about that. I will talk about the compressor and the selection, but we can talk a lot about the water level is what it is. The pipe, the loss in the pipe, we cannot do so much about it. And the disk diffuser, I assure somebody else will talk about that. But one thing I have seen in Denmark, nobody talking about the valves we control the air to the tank. There are a lot about how to do it. In the past, we have a lot of companies that were using butterfly valves to control the air to the tank. To do that with a butterfly valve, it could be very difficult. You need a big pressure loss through the valve to control the air to the tank. But there are other selections. What people do, or have done in Denmark, is reduce the pipe size 1 or 2 sizes. And then we can use the butterfly valve as this to reduce the air to the speed to the tank. But what we get is a lot of pressure loss in this valve. And if you compare with a valve in the same size, if you have 5,000 cubic meter air through this valve, you use 3.5 kilowatt more energy to this because of this pressure loss. Normally, like this, we have a half meter pressure loss. In this one, we have below 20 centimeters pressure loss. So this one is a nice place to the bird to get some heating in the winter time, because they're always quite warm in this area. When we go out and talk about the building, people always want to build a new big building to this compressor's house. But when we are talking about the LCC calculation, you need to take the entire installation, also the house, and then it can be very expensive to build a new house for compressors. And very often I have seen that we can use a small room, an old workshop, an old room, a stock room or something like that, and build in a compressor room because compressor is not so big anymore. The noise is quite low, so you can build it a lot of places. This one is from Køge in Denmark. And in the beginning, they talk about to build a new building for the compressors. And we're going around the treatment plant and I say, maybe we can use this small workshop you have here. And today, they have this very small room. We can deliver 24,000 cubic meters from this room. We have around 65 decibel noise in the room. So you can build a lot of compressor inside small room if you use the time to design the room in a proper way. But if we should build a new building, it's always good to think, where can we build it? If we can build it close to the tank, it is very nice, then we reduce the pressure loss to the pipe system. We don't need very big, nice building. We can do it in very small building. This one is a building we have used for pumping station. This is very cheap and efficient way to make a compressor house. We just come with the concrete, then we put in the compressor, and then afterwards we put the house on the fundament. So we made this compressor room on 2 days. But we can also talk about noise. Noise is one of the major issues in Denmark because some rules, for some reason I don't understand it, we have a lot of treatment plants inside cities. And we have all this complaint about the noise from the compressors. So when you decide to build a new compressor room, a new installation, you need to talk about what should the noise level be in the room. What can you accept of the noise level inside the room? You should talk about noise. We're always talking about noise, some noise, but low frequency noise and high frequency noise is not the same. Because low frequency noise can go through everything and can go far away. In Denmark, maybe you know it, we have a lot of windmills, and one of the biggest problems with windmills is you can hear this low frequency noise far away. Sometimes people can hear it 1 kilometer from the windmills, and this is also sometimes the problem when we are talking about the compressors. So you can talk not only about the noise, but also the frequency of the noise. Which level is can you live with outside the building? This treatment plant, on the other side of this compressor room, is probably a private home. In the past, the people could not live in their living room because there was so much noise. But after we changed the compressor room, we changed the inlet and so on, we have a very low noise outside the room. We have 36 dBA outside the building. So we need to talk about how to make good compressor room, how to take the air into the building and so on. Then there are some other small issues which you should talk about. This is this pulsation in the pipe, because you can have if you ask a sales company, they'll say, we have this noise level from the machine. It's true. You have a higher noise level in the room. Okay, that could be a problem. But we can make some pulsation out in the pipe. If you use stainless steel pipe, then you can get the whole piping work like a speaker. So the noise level inside the room, the noise level just outside the room is okay, but the pipe is making a lot of noise. You also should talk about that with your suppliers. When you decide to design your compressor room, one of the funny things is, when I come out, I have seen a lot of installations where people take the air from the room, from the compressor room. You can do that, but there's a price to pay. If you increase the temperature with 10 degrees, with 5,000 cubic meter, you increase the kilowatt consumption with 3.4 kilowatt around this area. So you should make the room so cold as possible, always taking the cool air to the machine. If you not have any other machines or heating company thing in the room, then you can do it. If you have something, then you take all the heating out of the room, because the machine don't need the heating. Otherwise, you can make a solution where you take the air from the outside, one filter to each machine. It's a very common way. But if you ask me, the best solution and also the most expensive solution is a manifold, where you make a manifold for the entire installation. You take all the air to all the machines. And why? Because we can get a very low speed in this channel. We can get a very low noise level in the room, but we can use the filter inside this manifold. So if we're only running with 2 machines in this channel, this is for 4 machines, the pressure loss in the filter is low. Then we use the filter capacity and reduce the filter pressure drop in the filter, and in this way we are saving money. So every time we make a selection inside the room, we also decide to have some energy consumption. I forgot to say, in this room we have 62 decibel inside the room.
Less than a rock.
Yes, okay. Then all machines have some energy loss. And what we are trying to do in the installation in Denmark, we're taking this loss from the energy cooling out of the room and heating another room beside the compressor room. It could be a workshop, it could be everything. You can use this heating for heating the room beside the compressor room. So take away, for one thing, this is good for the compressors, taking away this heating, but you can also use this heating. But now, this is the most interesting part of it. And when we are talking about compressors, a lot of customers call me and say, I need a compressor that can deliver 6,000 cubic meter air. Which ones should I choose? I always say, yes, you can choose what you want, but it will probably be wrong. Because we need to know a lot about the maximum, the minimum. We also need all the information about the duty points. Where have you the duty point? How many hours are you running in each duty point? We should also know something about your treatment plant. We should know something about, do you have a compressor for each tank, or do you have a big manifold solution? I can never say what is the best solution before we have go through all your data from your system, because sometimes the best solution is have 1 or 2 compressors to each tank. Other time the best solution is have a manifold solution. This is only your own treatment plant that can tell us what is the best solution. Then you also need to tell the supplier something about, do you have some special factory in the area that have a very short time where it make a lot of wastewater to the treatment plant? Because if you have that, you maybe should go through this time in the year, see what is the best solution in this time of the year, and try to find the best solution in the rest of the year. So you need to deliver a lot of information. And when I come out and ask for this information, the customer never have the data I need. They never have this data I need. So I get all the data for the SCADA system. And I can tell you, if you get data with kilowatt, pressure, hour, one data per each minute, for 1 month you get 45,000 lines. It's easily to handle this data in Excel. If you get it per second, you will get 2.5 million lines, and you cannot have it in an Excel sheet. then you need to split the months in two. But when we get this data, I will not go through this data with you now, but when we get it, we go through the data to see how it looks, how many cubic meter are you using, how are your time is running, because this is important to know, because every treatment plan has their own story. You will find out something about the pressure. I cannot make this one without all the data, but one funny thing with this pressure line is, if someone knows this pressure line, you can see there's some failure in the control system. This is not a failure from the compressor. This is not a failure from anything, but this is the SCADA system. They're making something here because they're closing the valve too much. So when we are running with the machine, they're closing the valve, and then the pressure in the net increased for no reason at all. So when we're making this analysis of the data, we can see if something wrong in the treatment plant. We can see, are there something happened with the valve, or happened something with the compressors, or so on. So everyone that run compressor on a treatment plant should know this line for their own treatment plant. And I expect you know it. This is only the Danish manager don't know it. Then you can talk about, should you deliver the air directly from the compressors to the tank? Sometimes this is the best solution. Sometimes you have this manifold solution. But when we are talking about energy efficiency, this way, most open valve is the best way to manage in compressor installation. Because when we're running the most open valve, we always have the lowest possible pressure in the net. So if you don't deliver the air directly from the compressor or blowers to the tank, then most open valve is the best solution. Each treatment plant, I have 3 treatment plants here. I will show you the data from 3 treatment plants. Have their own story to tell. This treatment plant is close to be similar size, but there are very big difference between the selection of the machines, because they don't need use the air in the same way. This treatment plant, we have sold different solution because they don't use the air in the same way. So the data tell how to select the machine. If you just ask for a machine that can deliver 6,000 or 8,000 cubic meter, I will make a wrong selection. So we need the data from you. There's also a small thing in this one. If you're looking in this area, you can see we are starting very fast with going up with 5,000 cubic meter. This tells us that the machine they have today is too big, because the line should look like this in the beginning. If you have this one, you can be sure the compressor they use today is too big. So you have a lot of things you can get from the machine, from the data. This is not the machine that tells the story, but this is your own data. This one is another treatment plant. In here, you can see we should have focus on a very small area in the treatment plant. There are a lot of need out here, but this is only a few hours. So we cannot take care of what is the efficiency out here, but we can take care of this area. This is the way we can look into this treatment plant. And the last one, again, is a different way to do it. And now I will try to use this again. Maybe. Yes. When we can make this selection, we need to go through the cubic meter and the hours from each solution. Sometimes I make 5 solutions, sometimes I make 7. the worst case, I make 12 different solutions because of the data, because you never know what is the best solution before you do it. And then we must go through how many kilowatt are we using in each duty point and make all this calculation. Then we must make a new calculation with other machines. I will see it come out here. Then we have try to do it with other machines and again with other machines. And when we have done that, we can see which of these different solutions is the best solution. So it takes quite a long time. To make the offer is the easy part. The analyzing of your data is the difficult part of this one. Now I will try to come back to the PowerPoint. I'm sorry. This one is quite interesting. This guy, he called me and said, I have several compressors. I would like to replace these machines. I know you have quite good machines. So I called and I visited. And he said, you should just replace what I have today. Okay, I can do that. But I know this will not be the best solution for you. So can I get your data? And then after some coffee drinking and talking about it and say, okay, you can get the data. But I know we have the best solution. If we replace this installation with machine by machine, the payback time will be 8 years. Then I get through all the data from this treatment plan, try to see, could we do it in a better way? Could we use the compressor in a better way in what we do today? And after 1 week using Excel, I could show him if we make a better choice, the payback time will only be 2.4 years. A little bit better in 8 years. Not so much, but there was a funny thing in this treatment plan. They had 2 different pressures on the treatment plan, and they used the same compressor to deliver the air, because it was too expensive to buy one machine for this low pressure tank. But anyway, we tried to do it. And it did, in this case, the payback time was 2.3 years. So if we only do what the customer had asked to do in the beginning, I would have sold more compressors. Our sales price was 3.5 million. In the end, we only sell for 3 million, but he get a much better installation. So ask the supplier to make the selection out from your data, not ask the suppliers to just replacing the compressor, because if you do that, you can be quite sure it will be very wrong selection. And one thing, a lot of treatment plan in Denmark forget, this is get a description how to use these new machines. And what they normally do is they start in one machine and running up from minimum to maximum load, and then they start the next machine and so on. And you could be sure this is not the right way to do it. You should always get the idea how the machine is running with the lowest kilowatt per cubic meter air. So go through it, ask for description how to control your new installation. This is, for me, more important in the machine, because if you buy the right machine but use it in the wrong way, you have not saved any energy. This first, when you use the machine in the right way, you save the energy. So always ask for this description. And before you sign a contract, there's something you should have focus on, because normally cubic meter, norm cubic meter, standard cubic meter in Germany This is not the same. So you always ask the supplier, what is the calculation? Is this 0 degrees, 20 degrees, or what? How have you made your calculation? But one thing you can be sure of, this is the discharge temperature from the machine is always the true value. So always ask, say when you're making this contract tender, we want this calculation, it's 0 degrees or 20 degrees, whatever you want. But always say this is the temperature you should use. Then you should also talk about the free air delivered. Because sometimes people talk about the air into the machine and not what we deliver. There's a small difference between these two. You also should know something about the pressure loss inside the machine. Because when we are putting this machine into it, we have some pressure loss in the filter, we have pressure loss in the inlet silencer, we have pressure loss in the outlet silencer, and we have a pressure loss in the valve. So you should put all this loss together and say, I want to have the pressure after machine, after the valve, and then I need the energy consumption, not from the compressor, not from the engine, not for the frequent converter, but the total energy consumption. Because sometimes there's a blower, sometimes there's an oil pump, sometimes there's something else. Ask for the total use of energy. I know I'm short of time.
One slide.
Yeah, one slide, yeah. Then you should be put in, and now I will say something that they don't like in Switzerland. Make a big penalty if we don't deliver what we have promised you. If we are saying we use 100 kilowatts in this duty point, and we're using 110, then we must pay for it. This is the only way you can be sure we're telling the true stories. Also, when we are talking about the noise level, if we say in this compressor room you will have 60 or 65 decibel, and you have 85, then you should say, okay, this is fair enough, then you must pay something for it. But because this is not a good way to handle customer, treat customer. The easiest way to be sure we are deliver what we are saying we will deliver is ask for a factory test. I don't understand. When I started with working with this one, no one asked for a factory test. Today, everyone in Denmark asks for a factory test because this is the best way to be sure we deliver what we have promised you. And last, if you want to have a good solution, use your data. Use your time in analyze your data. Use a lot of time in your data. And then understand the most expensive solution can maybe be the best and cheapest solution in the future. And know, sometime the compressors we will come with will be the same size. Sometime we will make different solutions with 3 different sizes of machine, because this is what your data is telling us. So this one is one of the treatment plan. The funny story with this one, I finished now, is this guy asked for 3 similar size machines with the air intake from the room. What the buy in the end was 3 different size machines with air from the outside the room, because we could show people save a lot of money to make this solution instead of this solution the after. Yes.
Okay, thank you, Robert, for this very interesting and practice-oriented presentation with many recommendations how to make the tender and what to ask the supplier. I guess this is more practice, so maybe there are questions from the practice side, or yeah. Thank you.
Hello. My name is Carsten Lüdicke from Berlin Waterworks. I have a question. If you, or do you have experience when you replace a big turbo blower, let's say 80,000 cubic meter per hour, with some smaller stems, let's say 6? Do you have any experience or data? How about the energy efficiency in this case?
We have not so big treatment plant in Denmark, I can tell you that. But last year we replaced surface aeration system in Copenhagen, or in one of the treatment plants in Copenhagen. And in this case, we make a bottom the diffusers, new flow boosters, and so on. And the energy saving in Avedøre is 54% of the energy in the past. So yes, you can do it, but I'm not sure if you have the very big compressors. Our compressor is the right solution, but we can do it.
Okay, thank you. I see no questions. And oh, Peter.
Peter Hartwig, Aqua and Waste International. One question: the right design of the controlling system for the blowers and the air input. Are you using also simulation models to, for example, also to verify the advantage of this open valve concept what we have? So are you using simulation with also detailed controllers inside to optimize the complete aeration system?
We have worked together with some Danish company on this one because we are not supplying this most open valve system. We are only selling the compressor and but we are working with a Danish company to do this, to see how much energy they can save when they're using this most open valve system.
So the recommendation of DWA to use the simulation models for the design, because then you can very much see the effect of the different controllers. That's just to go in this direction. Thank you.
So thank you for this comment. So I see no further